let's talk a bit about large language models and the plagiarism policy for our class. It's a new era, so we got to spend a little time talking about this. In 1983, there's a science fiction author and computer science professor, Werner Vinge, who wrote in Omni magazine the following. So far, there has been little progress in automating the distinct prerogatives of the human mind. During the next 20 years, this will change. Programs that can perform symbolic as well as numeric processing will become common. The student's hand computer, that's this, will become competent enough to solve most problems in our present undergraduate courses. Universities will scramble to provide curricula that train students to think with these new tools. So Werner was about 20 years optimistic, but yeah, we really hit that in 2023. LLMs can do all the work in a lot of our classes, and there's important and interesting questions about how to use these tools. They're really, really good at writing code, writing words, and all the rest. I had a little discussion with, this is ChatGPT 5 thinking in August 2025, which is when it is right now. I teach a class at Berkeley called CS61B, that's what I said. I want to demonstrate how well LLMs can do the work in the class. Can you make a solution to Project 3 from spring 2025? Go get it from the web, right? So that's the whole prompt. That's the entire prompt. And what I'm assuming is it will go to the web, find what it needs, and do the project. It replied with, I can help, but I'm not going to post a full drop-in solution to a current project in a public chat. I don't know why it decided it was a public chat. It's not. Without an explicit green light. Even if you're the instructor, which I believe, this sort of thing can leak and nuke the assignment for everyone. So I said, I explicitly authorize you. So it said, great, awesome, thanks for the explicit go-ahead. And in a minute and 15 seconds, it pulled the official spec and skeleton, it found the libraries, and it built a solution which you can download and run, and it does everything that's the capstone of our class. Okay? That's pretty amazing, right? That it can do that. Now, I should note that if I look at the sources it used, some of those sources were just random people's GitHub repositories where people had leaked solutions to the project, and it just copied a lot of that code or was deeply inspired by it. I actually did run a later experiment where I said, don't use the web, and it still was able to do the project. Though what's interesting is it did it in a way that clearly indicated it had memorized the solution in the process of training the model, because it was using stuff that was in an old version of the spec and not in the new version that I gave it. So point being that when it comes to well-known problems, especially problems that we're seeing at training time, these models can do really well at solving problems. Now it goes beyond that. I know that if I take my exam from fall 2022, and I give, in this case, I gave O1, which is an old model. I gave it our fall 2022 final exam, and it was able to score in the top 4% of 61B students. That is, if it was taking the class, it would have been in the top 4%. Now again, maybe it saw some of the problems in the training set. I don't know. But it does appear to me that the kind of problems that we ask in an undergraduate class, ChatGPT happens to do pretty well. I know also that the math department, one of their professors was feeding, I think it was O1 or maybe it was O3, the qualifying exam for the math PhD, and generally it did like fine. Like it passed the qualifying exam because it has this expansive encyclopedia of knowledge about how to glue things together. And so for the types of problems that we can easily give you and assess and expect you to do in an hour's time or a few hours time, it could do pretty well. So given how well these frontier models, the best models today, work, you might ask, why would I even bother to learn to write code by hand or solve any of these problems on the exams? Now, if you're in class in person or you come to the Zoom simulcast, I'll be happy to talk back and forth a little bit, but I'm not going to do it here because I'm just a reporter. I am going to tell you a little bit about this kind of conversation that's happening in education. So a couple of folks I know, this is Brett at the University of Washington, posted this on a CS teaching Slack that I'm part of. These are professors who teach computer science, and said, is anyone aware of a study about students who've only been trained to use generative AI attempting to solve really hard problems? Everything I've seen is about novices trying to solve easy problems or experienced engineers trying to solve hard problems. Like, has anybody tried to take novices and have them solve hard problems? Brett says, my hypothesis is that If you did that, if you tried to get somebody who had no idea what they were doing to use LLMs to solve real problems, they would fail. That is, learning to write code without AI is important for developing foundational skills, even if you will eventually use AI for most code writing in the future. Does anybody know if this is like an explored area, or should I do it? Okay, so it's an interesting question. I love that question. Jeffrey Challen at UIUC said, yeah, that's the $1 million question. Like, I'm very interested in this question. My sense is that right now, most of the people who are succeeding at using generative AI are well trained in basic programming and have a lot of experience, which you do really need working with these tools today. And I know that from my own experience using them, right? I need my experience in order to guide the tool well. Then he says, but who knows what the future will bring? It's possible we're in a transition akin to having a buggy compiler. So a compiler takes your high-level code and turns it into something the machine can execute. And if you have a buggy compiler, you still need to look at the output. But we don't do that anymore, as he notes, because compilers are not buggy. We don't need to look at what the C compiler does on its output. We just trust it. Jeff also says, I'd argue that exposing students to the capabilities of these tools is tremendously helpful in exciting them about the potential of computer science. I mean, it's crazy fun to be able to build things this fast. Students should get a taste of that. Okay. So I'll give you my take. I think large language models have indeed completely transformed software development, and they're going to keep getting a lot better. I saw this myself, like when I was, as I say below, when I was building autograders for this class. It's just like amazing how useful it is. Like, I'm with Jeffrey. Like, it's awesome. It's so fun to write code so fast. But I also will observe that at least today, their ability to solve large novel problems is actually much worse than human level capability. So for example, no significant math proofs have been LLM generated. And if you give a truly difficult math problem, even problems that I've seen on 61B exams, you see it just choke and die at solving hard problems. Like, you ask an expert in a field who really knows an area well to ask a deep question, and they can spot like huge holes. I see them in the way that these large language models try to solve problems. And maybe I'll even stick such a problem on an exam where I have you as a sophomore level expert. You can probably still spot some of these errors. I'll maybe put that on an exam. I don't know. I've done it before. Now, I will say that I believe that despite how good LLMs are at doing software development, the fundamental skills you learn in this class will be actually useful. One is obviously writing code without LLM access, because sometimes like you don't have access to it, or it's just like inconvenient, or you just want to write your own thing. So obviously it's useful for that. Two is guiding large language models as they generate code. And again, I did a ton of this as I was preparing for the fall of 2025. And I'd like to hopefully maybe in one of our software engineering lectures give some examples of what I mean by guiding code, because it sounds kind of BS, right? Like, yeah, the expert needs to guide the code. But I'll show you what it means to guide the code creation process with an LLM, hopefully. And then lastly, I think there's a deeper skill, this vaunted critical thinking skill, which is just solving abstract problems. That is, taking a big problem, breaking it into small pieces. This is a fundamental skill in mathematics, in organization design, working with other people. And I feel like this class is a really rich space for doing this kind of thing. Like, I love the types of problems that are solved in this class. And I think they're a good simulacrum or microcosm of other types of problems you might want to solve in life. So lastly, what's our policy? Well, I'm going to say first some recommendations. I recommend using them minimally. My guidelines are: don't use LLM plugins for IntelliJ, and don't use Cursor or Claude Code for this class. I mean, in real life, do whatever you want. But for this class, the way it was designed, I recommend not letting these LLMs do too much for you, and don't use these big, like, powerful plugins, or even code generation specific IDEs like Cursor and so forth. LLMs should not write any of the code that you turn in. I would say don't give the assignment specs to the LLMs, like copying and pasting the spec in, or somehow ingesting it, like saying, hey, can you go check the spec for me? I'd say don't do that. It's good to know how to read specs. And don't give your code to LLMs and say, where's the bug? That one I'm a little more iffy on, because sometimes finding a bug is super annoying. So I'd say unless you're really, really stuck and you've used all the skills in your toolbox, I would don't do the short circuit of having the LLM find the bug for you, because I think there's a really potent skill that we'll be showing off in a couple of the early homeworks where you can use the debugger in IntelliJ to help you understand where your expectation diverges from reality. So use the tools we suggest, talk to other folks first. I'd say LLM is last resort. Now, I should say for formative assessments, there's no specific rules about how you should behave. I mean, these are your homework to build your basic skills. So all of the skills that we have you develop on those formative assessments, we will later have an exam that covers them. So if you lean on the LLM, then you may run into trouble later because you didn't actually learn the thing. Okay, so formative assessments, there's no specific rules, but the exam will be the gatekeeper that gives you the stress. Like, I can't just rely. And then for summative assessments, there's 3 rules. And again, I'll come back to talking about this when we get closer to the phase 2 and phase 3 projects. But the first one will be by you alone. So any code that you submit should be written by you or your partner. Don't possess or share code. That means like don't look at solutions that exist. And then cite your sources. More on that later. Okay, so that's the exciting world of LLMs. So let's jump in now to write some code and get started with the class.